Franklin, welcome. As far as like when you take your test next week, I run statistics on it when we're done. And if the median falls below 88, that's where I provide an opportunity for you guys to either do a mini retest or some sort of test corrections, but to earn some points back. The last test we didn't do that because the median was 91. So that's why you didn't see anything going out there as an opportunity for that. The first test we did, but the criteria to be able to do that was you had to have all your homework in. One of the criteria that happens on this test, which this test is hard, so it very well may fall below 88 on that first run, but one of the criteria will be that you did the optional. So if you're choosing not to do this because you got this, that's totally fine. But just kind of know this is one of the criteria to do the optional review. This one right here is the one you're going to work on in class today and tomorrow. And then Friday, I don't add anything. So you have plenty of class time to do the one that's required. The optional one would be, and keys are provided for both of these, all right? Be careful how you use them when we approach a test. So what I want you to do is take out your notes, take out a highlighter. We're going to kind of just page through and highlight some stuff you have to know, okay? Because not everything in there is tested on. I cover everything, but I only test you on the AP stuff. So if AP doesn't test you on a skill, I won't this year. All right, so we're going to go to the notes and go to the very first page, and I'm going to get out my highlighter while you guys are finding your notes. Those of you at home, I highly suggest you find a highlighter. And do you guys see the little handprint? You see it up there anymore? Sometimes it hides on me. I don't see it either, so just a sec. I think I have to turn my tools on. So give me a minute. Let's all find our highlighters, go to the first page, and then when we're done, we're just going to work. Smart inking tool. There it is. All right, now we got it. All right, so grab your highlighters. And part of your studying for this chapter is obviously doing the review, but that gets done in class. Another thing is going to be looking through your notes. So the first day we did the chain rule, totally on your test. If you don't know the chain rule, it's not going to go well. It's all over your test. This is the formal notation that you really need to know right here. I will not test you on this other form over here. So in your notes, I'd highlight that. Also fair game with this is the second derivative in this form. And Jake, because this is a product, what rule would you use for taking the second derivative? Product rule. So that's fair game. Doing first d second, which would be g double prime, plus second d first, which would be f double of g of x. I mean, it's fair game. I'm not saying it's on there, but not this notation on the left. All right. So super important is the chain rule, and I want to talk about a couple of things I've seen with it. Be very careful. You do need to know this guy, that you bring the power out front, you knock it down, and then do the derivative of the guts. So this is totally fair game. Be sure you keep this in mind when you're doing higher order derivatives. This is what I mean by that. I gave an assignment. I do look at stuff so that I can bring it up. If you were doing the first derivative, you already have this in your notes, right? That it's 3 times 3x minus 2x squared. Knock it down 1 times the derivative of the guts, which would be, the derivative of the guts would be 3 minus 4x, correct? Now, if you were doing the second derivative, what rule would you use? Because now we know how to take second derivatives. What rule would we use for the second derivative? Go ahead, anybody. Product. Be very careful when you do first d second, that would just be -4. But when you do second d first, that's the chain rule. You'd bring the 2 out front, knock it down 1, and don't forget the derivative of the guts. Some of you were forgetting the derivative of the guts when you were doing second and third derivatives. You didn't on the first, but all of a sudden when it went to second and third, you were just going like 6 times 3x minus 2x squared to the first. And you're like, no, that's still the chain rule. Does that make sense? So watch out for that, but there's chain rule all over this test. All right, next up. Then, of these up here, these 4 are fair game. I think this one's on your review. You can go ahead and look. But on your test, I stick with those top 4. All right? And this is always super helpful. Your St. Cloud, negative St., negative Cloud, St., right? So that's always really helpful. All right, so trig derivatives are all over your test. So I want to review one of them with you. I want to talk about this guy. Okay? A very straightforward chain rule. I'm going to take, my glasses are fogging up for a second. I saw a couple people yesterday. You guys, it wasn't you guys because you weren't here, but they started the review. And when you take your derivative, remember with the trig, I said to get that outer function out here so you can see it. Remember that, Ava? Right? And you bring the 4 out front. You keep the entire guts intact, right? You drop it a degree, and it's the next one that people were goofing up on. And I suggest you run it all in one. That only took care of this. Mallory, what's the derivative now of sine of that? Cosine of that, right? Don't touch the inner function until you deal with the outer function. And then times what? 3. Some kids were missing that link when it was trig, and here's why. So I'll show you. Don't write this down. The kids who don't do it as one long string, they go like this. They go 4 sine 3x cubed. And then they go, what do? They go like this. Oh, that one's cosine 3x times 3. And then they just do that. Like if you work it vertically, they tend to miss a link. So I'd stretch it all out, Jake. Just in one long string. All right, next up, next page. You do need to know this one for sure. Natural log of u's derivative is u prime over u. Definitely know that. It's u prime over u. And you'll be practicing that, so I'm not going to do examples. I'm not going to put anything on the test where you need to know your logarithmic properties. That's pre-calc. But there's a bonus, and I'll show you what one the bonus looks like. So yes, you do need to know u prime over u for the derivative. Also, the derivative of e to the u. Yesterday, when I was watching them do it wasn't yesterday, it was the day before, I think it was you guys actually. There was one where it was e to the x squared. And it was a higher order derivative. Do you guys remember that? It was like the very first page. And when you do the first derivative of that, you get e to the u prime. So it's 2x, not just 2. And when you do the next derivative, Harrison, what rule do you need? Product. And so it would go first, d second is e to the u du plus second. Whoops, that was weird. D first. So just watch that, right? So be careful when you're using that you don't forget the u prime. All right, as far as these guys go, I'm not testing you on these. They're not on the AP test. All right, one might pop up on your review. If you were in college, you'd probably have one, but AP does not test this explicitly. All right, so we're good with that. You don't need to commit those to memory. Next up, the tabular stuff, definitely 100% know how to work your tables for all the rules. All right, so let's just revisit this guy. Remember when you're doing the derivative of a function in a function, that's not the product rule. So be careful with that, right? What rule is this one going to be, Harp? If I want to take the derivative of j and it's a function inside of a function, what rule will I use? Chain. And it goes, take the derivative of the outside, whatever it is. If it's sine, it goes to cosine. Don't touch the guts. Times the derivative of the guts. All right, so make sure you know that and you can read your tables. Next up, explicit versus implicit. Implicit's hugely tested. One of the FRQs is solely on implicit. So yes, totally know how to do implicit. And then I'll tell you what to watch out for. Watch out for, not here, not there. In your notes, I think, did you add some extra examples on the bottom? Maybe, I think I did add a couple. Let me go see it. On the bottom of that, flip it over once for me. Yep. Do you see those examples on the bottom that you guys did? Watch out for the one like the first one with that product rule in there. So I'm going to have you, you might want to write yourself a note. Watch out for product rule when you're doing implicit. And maybe I'll put a little sample here. Suppose it was e to the xy minus xy equals 9. Ugh. I just made that up, Ava. I don't know if there's one like that, but just in case, right? If you were doing this implicitly, you would take the derivative of everything. Right? Are we good? You guys are watching me like a hawk. What's the derivative of 9? 0. What's the derivative of e to the u? Go ahead and tell me, Franklin. What's the derivative of e to the u? E to the what? Do you know? What's the derivative, Ava, of e to the u? Yes. Now for the u prime, you have to be careful. Because what rule do I need to use for that? Product. First d second plus second d first. Beware of the product rule because it throws the whole thing off, Harrison. A lot of kids will just say that that's y prime because they do the derivative of x is 1 and the derivative of y is y prime. And it's going to throw the whole thing off. Same here. First d second plus second d first, and don't forget the parentheses. I'm not going to finish that one out. Just beware of the product rule in your implicit. All right. Next up, I will not be testing you on logarithmic differentiation. So don't highlight anything there, but it is your bonus. So your bonus is one like this. I think about 15 of you total watched the video, but if you're now, like if you didn't have time when it was out there, there's a video posted on a slide from last week that says the bonus for 3-3 or something like that, and you guys got extra credit for doing it. But you might want to revisit that if you're like, I think I could handle one. Otherwise, it's just bonus, so it'll add points to your score, but you don't have to commit any study into it if you don't want to. All right, moving right along. Next up was the inverse functions. This is on the test, but we didn't take notes in your note packet. We did it separately. So what I want you to do on your note packet is revisit, and then we'll highlight it. Just the main deal with inverse functions. What's going to happen is that it's going to say something like g is the inverse of f. Remember, it can say it explicitly like that. Or it might say g equals f inverse, something like, just so you know, you're going to have a function that's the inverse of another one. And it'll say to find g prime somewhere. So remember how this goes. This is the x value on g. So we go like this. A comma, I have no idea, is on g. That's f inverse. So I like to write f inverse. Do you remember doing these? And then we said that something comma a had to be on f. So go ahead and write that down. The kicker was finding this something. So highlight that. You need to find it either off of a table, right? Or plugging numbers in and saying what spits out, like if a was a 2, what spits out a 2? It's usually 0, 1, or 2. It's usually really easy to see. But you need to find that. So I'm going to call it B. But that's the kicker. It doesn't really matter that there's a B over here. So I would highlight that B, that you need to find that. It's either in what I call the pre-measured bowl, off a table, or it'll be something really easy to see. Do you remember doing this? So then what you do is you say, well, I'm going to find the derivative at b. Whatever that was. How do you find it? Maybe they handed it to you. Maybe it's off a table. Maybe you have to actually take a derivative and plug it in, right? How was the inverse function's derivative related to that number? So suppose you got f prime of b equals, and I'm going to make one up. Suppose there's one where Eva had to actually take the derivative of f. Maybe f was equal to x squared minus 2x, right? And suppose she says, well, then f prime is 2x minus 2. And maybe her b was a 3. And so she puts in a 3, and out pops a 4. So this ended up being a 4. That's not our answer. Right, Jake? Do you remember how were they related? It's the reciprocal. Exactly. The inverse's derivative at the corresponding spot is the reciprocal. But that's your process. They're going to give you the x value on the inverse. You're going to say, well, that's the y value on the original. You're going to have to find the x value, and then you do the derivative there, and then you flip it. Revisit that process because it's asked about, I think it's like 2 or 3 times on the test. There's an inverse question. All right, so let's move along. In your notes too, maybe you might want to revisit these. I'm going to highlight that one. Maybe just make sure you can work a table to find an inverse. And then 3, 4, inverse trig. Which ones do I need to know? Those. I'm not testing you on these. I think this one might be on your review. Go ahead and look, okay? But I won't test you on that. So you might want to think back to how you could remember those easily. So I'm going to kind of just talk about the notes really quickly. In the notes, I derived 2 of them. And I think I did arcsine and arctan. But I said, you know what, u prime is always on the top of these, so that's easy to remember, right? And the cofunctions are just negative of the originals, just like the derivative of cosine is negative sine. So you really don't need to memorize these 2. You just remember, well, it's the opposite of, so it's these 2 right here that need to be committed to memory. And I gave you a little way to do that. Do you remember what it was, Peyton? The tan one is prettier. And I said for 2 reasons. Otherwise, they're identical. They both have a 1 in the lead, a u prime on the top, and a u squared. But I said the tan one is prettier for 2 reasons. Do you remember what those 2 reasons were? How about Felicia? It doesn't have a square root, which makes it prettier. And what else makes it prettier? Addition's easier than subtraction. So it's not like super hard to remember them. So if you were to see cotangent on the test, you go, oh, tangent's that pretty one, u prime over 1 plus u squared, no root, and cotangent's just negative that. So it shouldn't be too hard to get those in your memory, but you don't have to do the bottom 2. All right, so what was next? Higher order derivatives. You do need to know that the derivative of position is velocity and the derivative of velocity is acceleration. You will be asked to do a, it's called a particle motion problem. But those of you who watched the notes yesterday, bless you, if it was calculator active, which I believe the particle motion one is, I'm thinking right, I think I put it on the part where you have a calculator on your desk. What's the easiest way to take the derivative somewhere if you have a calculator? What button do you use? Notes yesterday. Remember? Math 8. You might want to write that here. Math 8 if calculator active. Because here's what's going to happen. The people at home, unfortunately, who don't listen to these notes, right? Do you ever just not watch them? Right? And it's hard because they're not here, but they're supposed to watch these when I link it. And I wanted to keep it at 20 minutes, and I'm going to be close. But if they don't watch these notes, I'm going to just outright tell you, I'm very transparent about what's on the test. There's going to be a very ugly position function. I don't know, maybe it's like the cosine of the natural log of e to the 4x minus 7e to the x squared. And it's going to say find the velocity at 5 seconds. Those people not listening to the notes are going to go take this by hand. Not that it's impossible, but you could just go math 8 it and put a 5 in. Does that make sense? So kind of know that if it's calculator active, all you would have to do is tell me, well, the velocity is the derivative of position. So I'm going to go to my calculator. I mean, you can write this out, and you can just put that all in there when x equals 5, and then you can just give me an answer if it's calculator active. Okay? Do you see how dangerous it is to not listen to the notes? Poor B group, about 5 of them who never watch the notes, they're going to spend a lot of time trying to take that derivative by hand, and they're going to run out of time. Right? And they're going to say, well, I didn't finish on time. And I'll say, well, because you're doing something I said explicitly not to do in the notes. Oh, it's deadly. So be careful. All right. Next step. I think that was it. Because 3.6 was just putting it all together. But also 4.1, I have 2 questions on that where you're interpreting the derivative. Very similar to what you did on the worksheet yesterday. 1 multiple choice where you're just trying to decide what does this derivative mean in the context of this problem, like you did on your homework, and 1 calculator active, open-ended one. So math aiding it. All right, we're good. That's it. I'm at 21. I was close. So for you guys, take out your review packet. That's the one you're going to work on today, the must-do one. You get the next 35 minutes and all of tomorrow. So for tomorrow with them, I'm just going to say we're just going to work out your kinks. But I'm going to tell you on this one a couple things. Are you ready? Number 8. That's the bonus kind. So you don't have to do number 8 on here, but if you want to know if you can do the bonus, number 8's the bonus one. Are we good with that? And you'll notice that in here I do have some of the stuff I'm not testing you on because I like to give you a collegiate view of calculus and AP, but I only test you on the AP because that's what this is called. All right? So you will see a derivative of cosecant, and if you're like, oh, I don't know that one, go ahead and look. That's okay. The only other thing I want to tell you about this guy is don't forget there are, I think, 2 questions on here where you need to factor the way we did when we did common binomial factoring. And one of them's the very first one, so we're going to go do that one together. Okay, just to make sure you've got that down. Those of you at home, if you don't want to listen anymore, that's fine. I'm not going to take time to stop the video, though. We're going to go look at number 1, and it's y equals x cubed times x plus 1 squared root. Notice how I'm rewriting it? I want to see those powers. What rule am I going to launch into, Ellie, to find the derivative? It will have chain rule in it, but first and foremost, it's a what, Charlie? There's a function in a function. I agree with you. And if that x cubed wasn't there, I would completely launch into the chain rule. But first and foremost, it's x cubed times another function. So what rule are you going to launch into? Product. Let's go do that. So our dy dx will be equal to first, d second, power out front, knock it down 1. The derivative of the guts is 1, but I would keep that in mind because, Frank, had there been a number in front of here like a 5x, you need to multiply it by 5. It's just this one has guts of 1, Jake. Does that make sense? But beware that you did do, like Charlie said, the chain rule in there. So that's first d second plus second d first, which would be 3x squared. This you will not find, and this won't be helpful in answering some higher order questions. So first of all, you have to factor it. Correct? What comes out of both terms? For sure. Ava, give me something I can pull out of both terms. X squared is coming out of both. What else is coming out of both? Go ahead. How about who am I called on today? Kalia. Yes, and to which power? Thank you. the smaller one, even though it's negative. I can tell you must have watched the notes on common binomial factoring, right? Again, when you're at home and you don't, you miss this stuff, and it's really hard with distance learning with calculus because I need to see you every day and I can't. So make sure, all right, so that's what's coming out of both, Charlie, right? So then we put beefy brackets down and we put back what we need. So when we divide an x squared out of this guy, we'll have an x, but we still have the 1/2, so we actually have a 1/2 and we have an x. And I would dump it back in and make sure you have everything you need, but if you hop it back in, you get it right back, right? I'll need a plus. I'll need the 3. And I don't need anything else, I don't think, do I? I have the 3x squared. Oh, I do. I need an x plus 1 to what power? This is why I'm doing this one. How do we figure out the power? The same way as if we factor 4 of them out of here. Take out the smaller one, put back what you need. How do I figure out that power that's going to go in that black spot? Charlie can see it's a 6, but really what do you do with the exponents? Really? Subtract. High minus low. In this one, the high one is 1/2 minus negative 1/2. So it'll be to the first. And then we clean up in the beefy brackets. So we would have an x squared. I would send that to the basement as x plus 1. And then I'd clean up in the beefy brackets. I'd have a 1/2 x plus 3. So what is that? 3 1/2, 7/2 x. I'll just do it like that. Plus 7/2 x. Oh, sorry, times. Yes, times 7/2 x plus 3. That's good enough. How'd I do? Great. Now I'm going to ask you 2 questions and then I'm shutting the video off. What if I asked you, where on the graph of y, or f, is there a horizontal tangent line? Thank you. You say, well, that's where the top equals 0. There's 2 places. At 0 and you'd have to set the other one equal to 0. I don't want to do it. How about if I said, where is there a vertical tangent line? The bottom would have to equal 0 at x equals -1. And if it said the points, then I'd have to go back and plug it into the original function. All right? So, and this was, I didn't ask that on this. So we're done. You guys go ahead and work away. The key is posted. I would maybe do a full page and then check that full page. And if it's wrong, I'd highlight what's wrong. So use the key really wisely. If nothing's highlighted on your first page, once you check it, Charlie, don't study your first page. If you go through the whole thing and it's all right, don't do the extra one, right? And don't study anymore. You got it. All right, so you kind of decide, but at a bare minimum for the test, you need to complete this packet by Monday. Plenty of time with tomorrow and Friday. All right, so go ahead and work away, and I'd use the key, but make sure if you did something wrong, you highlight it, so you know that's something you need to look at. All right, over and out, people.